Welcome to Decode It, a podcast series helping understand more about computer technologies and its beginnings. I'm Ashley Griffin, involved in IT from the 1980s, first with the Atari ST, then onto computer networks in the early 1990s. Wi-Fi started on the 21st of September 1997, a method to allow a device to connect to a computer Ethernet network without cables. This might explain why when I first used it in my job as a network specialist and administrator in 1998, it was flaky at best. After connecting for a few hours, it would just stop moving data. The Wi-Fi symbol, which is the word Wi-Fi backed by a circle, is a trademark of the Wi-Fi Alliance. Devices tested to the Wi-Fi Alliance standard were labelled as Wi-Fi certified. All others were labelled Wireless LAN or WLAN. 2017, the Wi-Fi Alliance consisted of more than 800 companies. There were just over 3 billion Wi-Fi devices in 2019. Wi-Fi is designed for use with Ethernet and supports parts of the IEEE 802 protocol, which stands for the Institute of Electrical and Electronics Engineers. In 1989, a team of specialists in Australia were working on wireless LAN technology. In 1992, a prototype was developed, which was submitted as a patent. In 1991, NCR Corporation and AT&T invented WaveLAN, which was designed for use in retail as cashier systems. NCR's Vic Hayes and Bell Labs' Bruce Ruck held the chair at the IEEE 802.11 for 10 years. They approached IEEE to create a standard which resulted in the 802.11a and 802.11b specifications. In 1997 saw the first version of 802.11 protocol with speeds of 2 megabits per second. Then it was enhanced in 1999 with 802.11b with speeds of 11 megabits per second. 1999, the first major commercial breakthrough happened with Apple's release of iBook, calling the Wi-Fi Airport. Wi-Fi uses a large number of patents held by multiple different organisations in Australia, USA and the Netherlands, all claiming to be the inventors. Wi-Fi is not an acronym for wireless fidelity, although those words have been used in the original marketing. It's a shortened, easy to remember name for a group of technologies for wireless connection. The same as hi-fi broadly means music and hardware rather than a specific audio device. It is, however, specific to Ethernet. Although Zigbee, Z-Wave and Bluetooth all use same radio frequencies, they are their own technologies and protocols. Wi-Fi is a direct replacement for a cable or fibre connection to a computer. However, being wireless, it's not as robust and it still requires the IP communication layer to move data. So just having a Wi-Fi connection doesn't mean it's on the LAN. Wi-Fi uses radio frequencies and bands, why a country has to be set to adhere to local laws about radio usage. Letters were added to the end of the protocol to help remember the connection specifics, listed here in date order. 1977 802.11, which was 1 to 2 megabits per second using 2.4 gigahertz radio. 1999 802.11b, which was 1 to 11 megabits per second, also 2.4 gigahertz radio. 1999 802.11a, which was 6 to 54 megabits per second. This was an amendment of the original specification and it used the 5 gigahertz radio. 2003 802.11g, which is 6 to 54 megabits per second. That's using the 2.4 gigahertz radio. 2009 802.11n, which is also commonly known as Wi-Fi 4. That's 6.5 to 600 megabits per second, using 2.4 and 5 gigahertz radio. 2013 802.11ac, commonly known as Wi-Fi 5. That's 6.5 to 6,933 megabits per second. That's using the 5 gigahertz radio. 2021 802.11ax, commonly known as Wi-Fi 6, kind of new for now. That's 0.4 to 9,608 8 megabits per second using 2.4 and 5 gigahertz radio. There's then a specification in 2021 for Wi-Fi 6E, which is using the 6 gigahertz radio. 2024 802.11be, that's Wi-Fi 7. I'm just seeing that start to come around now. That's 0.4 to 23,059 megabits per second using 2.4, 5 and 6 gigahertz radio. The latest one, which is 802.11bn, that's Wi-Fi 8. That's 100,000 gigabits per second using 2.4, 5 and 6 gigahertz radio. At the company I worked at in 1998, we had purchased wireless access points for the sales laptops. Some had the Wi-Fi logo, others had WLAN. I never understood what the difference with this was until I've just done this research. A single access point antenna is easy to install and set up. Increasing coverage is harder work, requiring multiple access point antennas. Connecting them together is known as unification. They all work as a single access point. The mobile device can then move around, jumping from antenna to antenna. This wouldn't work well for streaming data like videos and voice calls, so new protocols were created to help, being 802.11k, 802.11r and 802.11v. The access point and the mobile device need to support these protocols for them to work, and I noticed that the Apple iPhone, the current iOS, does support them. So 802.11k helps with the device quickly finding the best available access point. 802.11r reduces the time it takes to switch between the access points. 802.11v enables network devices to share information, assisting with moving to new antennas. Wi-Fi unification is a complicated method to install, and it needs a layout design first. We have installed it and assisted other IT companies. Generally, unification is a cloud-based solution. Ours are fully on-premise, which would be known as private cloud, supporting up to Wi-Fi 7. Each access point can sustain up to 300 devices. Most access points are 50 to 100 maximum. We have them in large corporations, public attractions and places like car dealerships. Wi-Fi is mostly a luxury, as the hardware is more expensive than copper cabling. Other countries such as Tanzania, depending on how you want to pronounce it, and the Maldives, Wi-Fi is still very proprietary to the phone provider. Some installations having 10 or more cell phone connections, each providing a single Wi-Fi coverage. Our hardware solutions will allow a single internet cell connection to be spread around the building or island for full coverage, as they are a unified system. Being purchased and privately owned means it's a single outlay cost instead of rental. Large locations like hospitals or hotels, it's ideal as a full multi-building and parking area coverage is attainable. Other locations like resorts in the Maldives means whole island coverage with a single internet connection is possible. All hardware would be owned and controlled by the business rather than the service fees for multiple cloud serviced hardware antennas. This solution allows for walking around a whole island in the Maldives with a Wi-Fi phone, never dropping a call, as it's all handled by the privately owned on-site unified Wi-Fi communications network. The same network can be used to distribute the internet connection to everywhere, fully secured and controlled by the owner. Wireless communication remains working with no internet, no service or rental costs. Being fully on-premise, the wireless communications network would remain working with no internet and no service or rental costs. We own Wi-Fi testing hardware to install and configure access point antennas. We invested in the equipment to provide you full control over your data and the ability to offer your clients better service than your peers who are utilizing rental cloud-based systems. Some examples of uses for wireless coverage include point-of-sale units, roaming digital voice handsets, or known as VoIP and SIP, roaming tablets, such as inventory control, public information boards, and guest use anywhere in the resort or island beaches. Used where a physical connection isn't possible, such as a boat or ship while approaching the island, allowing for free, secure and in-house controlled communications. Perfect for both corporate and guest use before actually arriving at the resort. Thank you for spending some time with me. Subscribe to see more in the Decode It series.